Greetings, math students, from Mrs. Marcellus and Baratosthenes. We finished our souvenir shopping, so we thought we'd finish up the lesson we started on comparing and ordering fractions, decimals, and percents. If we remember, in the first part of the lesson we worked only with fractions. Today we're going to add in the other pieces. The learning objective is still the same. Students will compare and order fractions, decimals, and percents by converting them to a common format and applying their knowledge of place value and equivalent fractions. The vocabulary is the same as Part 1 as well. You don't need to record anything unless you didn't write it down the first time. We'll still be using the greater than, less than, and equal to symbols. Are you ready to try some problems? I think he's ready, so let's begin. In our problems today, we're going to be comparing values that are in different formats. The easiest thing to do to compare them is to find a common format. And that might depend on you. Some people find it easier to turn them into decimals, some people like percent, some people like fractions. There are multiple ways to do these problems, and you need to do which one works best for you. One thing we could do here is convert both of them into decimals. We know that every fraction is a division problem, so we can write 3/4 as 0.75. We're then comparing this to 0.7, or 7/10, and it's always good to add on a 0 so they're both the same length, and we can see that we have 75 hundredths compared to 70 hundredths. Therefore, 3/4 is greater than 7/10. We also could compare these values by turning 7/10 into a fraction and then using cross products to compare the two. 7/10 written as a fraction is 7 over 10. I could then use the cross products, multiply 10 times 3 to get 30, and 4 times 7 to get 28. If I compare 30 to 28, 30 is greater than 28, which means 3/4 is greater than 7/10. You also could convert both of these to percents, but I probably wouldn't go that route because in order to get to the percent, you have to go through either the fractions or the decimals. It's not the most efficient way, but you could still do it if you wanted to. In this problem, we're comparing 85% to 7/8. I would probably turn these both into decimals. To turn a percent into a decimal, we move the decimal 2 places to the left. This gives us 0.85. To turn 7/8 into a decimal, I divide 7 divided by 8, and that gives us the answer of 0.875. If I want to compare the two, I can add on a 0 to make them equal length, and I can easily see that 850 thousandths is smaller than 875 thousandths. Therefore, 85% is less than 7/8. You also could have left the original value of 85% and simply turned 7/8 into a percent as well. First we make it the decimal and we move that decimal over 2 places. That gives us 87.5%. 87.5% is the larger value, so we would still get the same answer either way. Another thing we could do is write 85% as a fraction and compare the cross products. Every percent is a number over 100, so that means we could write 85 over 100, and then we would cross multiply. Remember, we always have to go from bottom to top, so we could multiply 100 times 7 to get 700. And then going the other direction, 8 times 85 gives us 680. Since 680 is less than 700, 85% is less than 7/8. So as you could see, we could solve this problem by converting both of the numbers to a percent, to a fraction, or to a decimal, and all three of them work just as well. You have to do which one makes the most sense to you. When we have a decimal and a percent, there's really no need to involve fractions because we can easily move that decimal to the left or to the right. I could turn 6.5 into a percent by moving the decimal 2 places to the right. And I can see that I end up with 650%. Therefore, both sides are equal. 6.5 is equal to 650%. You also could have easily turned the percent into a decimal by moving the decimal 2 places to the left. 650% written as a decimal is 6.5. So whether you convert the decimal to a percent or the percent to a decimal, in this case they are equal. Next, let's compare 2/3 to 6/10. We can write 6/10 as a fraction and compare the cross products. 6/10 written as a fraction is 6/10. We would then cross multiply bottom to top. 3 times 6 is 18. 2 times 10 is 20. Since 20 is greater than 18, 2/3 is greater than 6/10. Another thing you can do is turn the fraction into a decimal. 2 divided by 3 gives us 0.6 repeating. We want to compare that to 6/10. If I keep writing out the 6's and the 0.6 repeating, in order to make the 6/10 equal in length, I would add on zeros. This clearly shows us that 666 thousandths is greater than 600 thousandths. Therefore, 2/3 is greater than 6/10. There's really no reason to convert these values to percents. Doing so is probably the most complicated way to solve the problem. Here we're going to put the values in order from least to greatest. Just like when we were comparing, there's really not one right or wrong way to do these problems. The important thing is that you put all three of them into a common format. If I was doing this problem, I would probably use decimals. First, I would use my knowledge of every fraction as a division problem and divide 5 by 8 to get 625 thousandths. Next, I would turn 5/10 into an equal length decimal. I'm not really changing the value or doing anything to it, but I'm adding on 2 zeros just so it matches the length of the first one. That's not required, but sometimes it's helpful when you're comparing, especially if the numbers are really close in value. For the percent, I would move the decimal 2 places to the left. This gives me 583 thousandths. Next, I want to compare. If I just kind of ignore the 0 and the decimal, I can just look at these as whole numbers. 500, or 500 thousandths, is the smallest value, so I know that 5/10 is the smallest of the three. Next would come 583, so I know that 58.3% would be the second largest value, and then 5/8 is the one that's left, and it is the largest value. It probably is not the easiest thing to do to convert all of these into fractions. You could have made the first two percents and then working with the 58.3%. Either way you decide to do it, you'll get the same answer. Bear and Tosthenes decided to bring home bottles of Bermuda honey for our friends. We all know that bears just love honey. 3 different brands are made up of 1/5, 22 hundredths, and 19% carbohydrates. List these values in order from greatest to least. This is where it's really important to read the directions. We want the greatest value first and the smallest value last. We'll start with the given values of 1/5, 22 hundredths, and 19%. It's probably just as easy to write these as percents as it is decimals. I'd stay away from the fractions though, because that would involve the most work and would be the most complicated route to go. We can easily turn 1/5 into a decimal. 1 divided by 5 gives me 2/10. And in this case, I'm going to add on a 0 just to keep the numbers the same length. So when we compare, we're looking at the hundredths across the board. 22 hundredths is a decimal, so I don't need to change it. And 19% can easily be written as a decimal if I move that decimal 2 places to the left. Remember, the question asks us to order these from greatest to least. The greatest of these would be 22 hundredths, so that would come first. That would be followed by 20 hundredths, which means that 1/5 is the second largest value. Then finally, the smallest of the three values is 19%. You notice when I do my final answer that I write the numbers in the original form, and that is what you should do too. I could have also made these all percents. If I had done that, I could have also easily seen that 22% was the largest, so 22 hundredths would be first, and that 19% was the smallest, and I still would have ended up with the same answer. Well, Beratosthenes, that was kind of fun, wasn't it? I think that we sure do have this mathematical Bermuda Triangle thing mastered. We can easily convert among fractions, decimals, and percents. Boy, we sure will have a lot to tell Einstein and Pythagoras when we get home, won't we? And hopefully they'll like their honey, too. Well, bye for now, math students.